Hey everyone, we are back for another episode of The Power of Vue 3 Function Refs. So I recorded the initial 3 episodes of this kind of mini-series a few months ago. Since then, I've been putting a bunch more work into my Baliata features library, which is a bunch of different Vue 3 composables, all powered by function refs under the hood to do cool stuff like accessible list boxes and managing all the keyboard interactions and stuff like that. Just basically taking tons of UI logic that's pretty tricky and putting it into composables where it can be nicely organized and tested and extracted. So that's been a super fun project. Learned a lot as I've been expanding on that over the past few months. And one thing that I explored in that project that I want to do another kind of intro episode here on is storing elements in custom data structures with function refs. So in order to illustrate that concept, and we'll get into more of what that means in a little bit, but in order to illustrate that concept, I have here a grid rendered out on the screen, just a 3x3 grid with some basic kind of contrived metadata here. So we are rendering this table metadata, which is an array of arrays. So you can think of this as like each array in this array is a row of data. And each item in the row arrays is a data cell. So that's kind of the metadata we're working with here. And then in the template, if you look at this little chunk of markup, I have a nested v4 rendering this. So I have a top level v4 that's iterating over the rows in the table metadata. So v4 row, comma row index and table metadata, and is rendering those out. And then nested inside of that, we're iterating over the row itself. So we're doing v4 cells, comma column index in row, and we're rendering out the cell contents. So if you've ever rendered a table in Vue, maybe you didn't take this approach exactly, but I would guess that if you rendered a table based on metadata like this, whatever you did was probably pretty similar to this. This nested v4 thing is a fairly common way to render tables out. So the question we have at hand now is, how can we store these cells? Let's try and get a reference to each cell and store that in a template ref so that we can do things programmatically with those cells. For example, if we were building an accessible grid, we would want to set the ARIA selected attribute on each cell based on whether or not that cell has been selected or highlighted. Or we'd want to we definitely want to add the grid cell role, for example. So there's all kinds of different stuff that we could do from inside of Composable if we got access to these cells programmatically by template refs. So let's try the obvious approach first, I think, which is just using a normal template ref, not even a function ref. So we'll import ref from Vue, and then we'll say const grid, we'll say const cells equals ref, and then we'll just use the string. We'll set the ref on this nested v4, we'll set that to cells. And so yeah, not a function ref, just a normal ref here. And if we actually log this out to the console, let's also grab onMounted from Vue, and we'll say onMounted console.log cells.value. What you'll see here, I'll flip into this other view and we'll get a clean console. What you'll see is that we get here it is. We get a flat array. So a flat array, all the cells are here. We do get references to each one, but the data structure is not particularly useful. Like imagine the user had clicked on cell number 3 and then they press command right arrow on their keyboard. And so the normal thing to do with a grid like that is you would want to move focus to the end of that particular row. So in this example, maybe it's a little bit easier to figure out that it's, index number 5 here that is at the end of the second row. But if this is a more complex table, maybe with certain cells being merged or something, it's at the end of the day, it's just not, the flat array is not the best data structure that we could have to figure out where we are, what are our coordinates in this grid, and what should certain keystrokes do to change our focus or select different items or whatever. So what we're going to look at instead is how we can use function refs to store this data in a custom data structure that serves our needs better. So we will get rid of this code and get rid of that flat array, and we'll move into a composable. We'll remove this ref as well. We'll move into a composable, just a little file I created here called useGrid, And you can think of this as the composable that we would be writing to add all this kind of accessible functionality and any other features that we might want to add to our grid. So first thing we'll do here is we'll set up our, we'll try to get a function ref going. So const cells equals ref. And I think what I want to try to do first is store the elements to match the original data structure here. And I think that often is going to be the right call. You want to figure out what's the data structure that is going to be rendered on screen. What are the developers rendering this grid? What are they working with? What can I do to make sure that the elements match that data structure? So for this use case, we're going to try and get an array of arrays, but the items in the array, instead of being these numbers or whatever other metadata for this table, we want them to be the actual elements that render as the cells. So in this first item here, we want this to be the element for the that's rendered out for the 0 here, and this should be the 1 element, and this should be the 2 element, etc. So we want to get an array of arrays where our elements are nicely organized the way that the original data set was also organized. So what we can do is write a function ref, and we'll say const function ref equals, and we'll get some parameters in there shortly. What we want to accept here is the element, of course. We need to know the element. And then we need to know the row and the column. And those would be the numbers, the index space position. So what row is this element in and what column is it in? And then once we have that inside of our function ref, we can do a couple things. First, we'll check to see if the element is actually there. So if there's no element, we want to return. Sometimes in Vue, function refs can be called with a null value for an element. Actually, this is even more common in React, where callback refs, they're called callback refs instead of function refs, but they also work, by the way. So a lot of these same concepts carry over into React as well. But yeah, so the element sometimes can be null or something, so you generally don't want to do anything if you detect that that's the case. So once we know that there is indeed an element, what we can do is we can check if cells.value, and we'll check the row. If there's nothing in the row yet, because right now we're initializing cells with just an empty array. So if we're checking like row 0 or row 1, in theory there could be nothing there at all. So if there's nothing in the row, we want to set up an array where we can start to put stuff in. So cells.value square brackets row equals empty array. Now that we know we have an element and we know we have something in the row, I think this is all just TypeScript stuff, right? Complaining? Yeah. Maybe if we just do this, TypeScript will stop yelling at us. Yeah, that should be fine. So now we know we have an element. We know we have an empty array in the row for that element. And so now what we can do is cells.value. We'll access the row and we'll access the column. And we'll store the element at that position. And now we can do onMounted. And we can console.log cells.value. We'll return this function ref from our composable. And then back in our template, we'll import this useGrid function. Import useGrid from useGrid. We'll say const cells ref equals useGrid. And now we can bind this function ref that we got back from our composable. It's ready to go. We can bind it to this nested v4 to get all of our elements. So what we can do here is ref. We'll get the element here is passed to the function ref. And so then we'll do an arrow function. We'll say cells ref, and we'll pass in the row index. Oops, first we want to pass in the element, then we want to pass in the row index, and then we want to pass in the column index. And that should be everything that our function ref needs to grab all of these elements out of the DOM and store them in a position in our reactive reference that makes sense for us to work with internally inside of this composable. And we're logging that out to the console, so we should be able to refresh here. And maybe I did not const cells ref, typo. So here we go. Fix that typo, reload here. And now we're seeing that we are logging to the console an array of arrays, and each of those arrays is a row of data. Each item is a row of data, and inside of those rows of data, we see that our elements are properly stored. So yeah, having worked for the past couple months on a real-world use-grade composable with all kinds of different features and functionality, I can tell you that this sort of custom data structure is way, way more useful and way easier to reason about when you're writing complex UI logic to interact with it, to update selection, or if you're doing like any kind of, you click on a certain cell and then you drag with your mouse, that should update the selection to a bunch of different cells. All those kinds of interactions are really difficult to do if you just have a flat array. But once you're working with a more custom data structure like this that is designed specifically to support your UI logic needs and different features that you're implementing, everything gets way, way easier. So yeah, the greatest thing too about this is that we don't even have to do, for a case like this, we don't even have to do an array of arrays. We could do anything in here. So let's try it. Instead of doing an array of arrays, let's do a map. So we'll initialize this with a new map. And then what we actually should also do is on before update, we should be emptying this out. So we'll do cells.value equals new map. This basically will ensure that our reactive reference doesn't contain any stale data if this table gets filtered or sorted or whatever. Emptying this out between each update cycle is going to make sure that our function ref refills it with the new elements in the correct order, matching the way that they're rendered in the DOM. So that's a little detail that I think we covered in episode 2 of the original series when we were looking at rendering lists, and it applies for these kind of custom data structures as well. Anytime things might be changing order or changing length or whatever, you want to be emptying out your data structure in between render cycles. So we do that little reset, and now in our function ref we can do something like let's say cells.value.set, because this is the map, so we have the set function, and we can use the element as the key, and then we'll store the row and the column as the value. And then we're console.logging that. So we reload here. We don't have to do anything else in our template. Again, right, with our template, we're just still getting that cells ref, binding it to the element and passing in the same parameters. So there's like, you can swap out custom data structures, change it for anything else you want, and there's basically no impact on the developer experience of people using this at all, which is super cool. And then if we look here in our console, we have a map with 9 entries, and each one of those has the original element and also its coordinates. So this could be cool if you're doing something like, let's imagine we're detecting a click on element number 3 here. So if I grab this element and I use it as a global variable, and then let's also store our map as a global variable. Now we can do temp2, which is our map, dot value, we want to do dot get, and then we can pass in temp1, which is the element that we grabbed. So this should give us, so this gives us the coordinates of that element. So imagine this element was clicked, number 3 was clicked, and then we grab the event.target out of the click event, and then we can look up, using that event.target, we can look up the coordinates of exactly the element that was clicked, and we can decide to do something based on what those coordinates are. And so custom data structures, you can literally do anything you want with this. There's no limits on what you can do. If there's some sort of structure that makes sense for your app or for your use case, you can implement that internally with a function ref. Your users will be none the wiser, and you can do whatever you need to do with your composable. So last detail here before we wrap up is this ref here, this usage of ref. In this case, it's not super necessary, and it's even a little bit less performant than using instead shallow ref. So we're going to swap out shallow ref here, and I'm going to do another video where I talk about a few other concepts that I either missed or stated incorrectly, or there have been changes over the past few months about function refs compared to the original series I did. The usage of shallow ref is one of those. So in the original series, I had mentioned that shallow ref is good for non-reactive data that you want to keep around for the full life cycle of the component. And that's not totally accurate, because shallow refs actually are reactive, but they're only reactive when you do a full value replacement. So if I were to do something like cells.value, or imagine this is an array and I did like sort on the array. This dot sort, on a normal array, if you constructed that array, if you did that with ref in Vue, this would trigger reactive updates, because Vue would detect, okay, this sort method is changing this array reactively, and we should update the template, re-render the template based on that. If you do that on a shallow ref, the shallow ref doesn't go down deep enough to detect that level of change. So it will only run reactive updates when you replace the entire value with something else, like cells.value equals an entirely new thing. So with function refs, usually that's what we want, especially when working with custom data structures, for two reasons. One, we don't want to encourage anyone to be mutating these data structures at a deep nested level. Like, the function refs are designed to store elements in a reactive reference. You shouldn't then be going into that reactive reference and mutating individual elements inside of it or stuff like that. You should think of them really as read-only data structures. Because if you start to mutate them and do other stuff, really quickly you'll start to find bugs that are really hard to debug, or side effects will happen at the wrong time or stuff like that. So think of these as read-only. You don't want to be generally doing anything other than a full value replacement and then letting the function ref refill your reference with new data. So for example, on this onBeforeUpdate hook, setting cells.value to a new map, that will trigger reactive updates and a re-render. And by the time that view runs that re-render, our function ref will already have run again and refilled that new map with our elements. So we're not like creating situations where we'll reach into this map or this custom data structure, whatever it is, and we'll find that our elements are missing. Our elements are always going to be there at the time that we need them to be there. And the advantage of using shallow ref is that we don't have to worry about other kinds of changes triggering reactive updates when it's not supposed to happen, or triggering infinite render loops or anything like that. So these traps are kind of easy to fall into when you're working with complex custom data structures, and using shallow ref instead of ref is a really nice, clean way to just avoid that entire minefield of complexity and make sure that things just function the way that you expect them to. So that is a nice little overview of how to do custom data structures with function refs. Again, I think the most powerful thing to know here is that all of the implementation details of what data structure you're using and how things are getting stored, that happens inside your function ref, and it's totally invisible to the people that are binding this function ref to the elements in their template, which means that if at any point in the future you come up with a different idea for your composable or your library, and you need to swap out the data structure for something else that makes more sense and is easier to work with for whatever feature you're trying to implement, you can absolutely do that. You can update your function ref internally to store things differently or move them around differently, and there's no impact on the people that are importing your composable and using it in their applications, because all this stuff happens in a function behind the scenes and you have total control over it. So really fun stuff to think about. It's been really a nice little adventure to implement this use grid composable in my own library and learn some of the stuff and explore it more deeply. I'm always more convinced of the power of function refs, and seeing them do stuff like this, it cleans up a lot of mess and complexity in my own code bases, and it's been fun to work with. So hopefully you find this interesting, and yeah, there should be another video in this series coming out soon, doing basically a wrap up and talking about some updates to Vue that have made things a little bit easier with function refs, and talking about some other stuff too. So look forward to that, and I will see you in the next one.